So now we're going to calculate in this third video the delta H of a reaction. So let's just review what the delta H of formation is. The delta H of formation is the amount of heat energy it takes to form the compound. So we said that elements in their most common state have a delta H of formation of 0 of kilojoules per mole. But what about a compound? So let's say, let's just take sugar. And let's take water. Okay, what is the delta H of formation of water? Now we have to specify what phase of water. So let's just say liquid water. Okay, so the delta H of formation of a compound is when you form the compound from its elements. And when I say form the compound, I form 1 mole of the compound from its elements. So the reaction would be, okay, we're going to form H2O liquid. Well, what do you form H2O from? What elements? Hydrogen and oxygen. Okay, so we have 1 oxygen on the product side, but 2 oxygens on the left side. We must keep a 1 there, okay, because it's 1 mole of the compound. So we must keep a 1 there. So that means my only option is then to put a 1/2 there. And then you look up in the back of the book, it is table Appendix 4 in the back of the book, pages 820 through 824. And so the delta H of formation of water, liquid water, is negative 286 kilojoules per mole. If we did it for, let's say, sugar, sugar is C6H12O6. Okay, this has to be 1 mole. So it would be forming it from carbon, hydrogen, and oxygen. So in order to balance it, I would need a 6 there, and I would need a 3 here. And I would need a 6 out in front of the carbon. And then you could look up the delta H of formation of sugar, and the delta H of formation of sugar is, when I forgot to specify solid sugar, it would be negative 1275 kilojoules per mole. Okay? So how about an entire reaction? Okay? To find the delta H, the amount of heat given off by a reaction, little r stands for reaction, you do the delta H of formations of the products minus the delta H of formation of the reactants. Okay, and for each individual product or reactant, you multiply them by their mole ratio. So this is pretty simple. We'll do an example with sugar. So let's combust sugar, C6H12O6, combusting with oxygen gas, solid sugar, to yield, that's gas, 6H2O liquid plus 6CO2 gas. All right. So to find the delta H of the reaction, we're going to do the delta H of formations of the products minus the delta H of formation of the reactants. So what I usually do is I write the delta H formations below each substance. Okay. Liquid water was negative 286. So we have to look up carbon dioxide gas. CO2 gas is negative 394. These are all in kilojoules per mole. And then what's the delta H of formation of oxygen gas? Well, oxygen is an element, and it's in its most common state, so 0. So now we do the products minus the reactants. And then we have to multiply them by their mole ratios. Okay? So I would take, I would take 6 times negative 286 plus 6 times negative 394. So those are my reactants. And then I would subtract the products, which would be negative 1276 plus 6 times 0. So if you plug that into your calculator, I get negative 2004 kilojoules per mole. Okay? Now that per mole is per mole of everything in the reaction. So it's per 1 mole of sugar. It's per 6 moles of oxygen. It's per 6 moles of water and 6 moles of CO2. So you have to take that into account. What is the mole number out in front of the substance? Okay? So if you were to then have a follow-up problem like this, how much energy is released when 15 grams of carbon dioxide are produced? Well, it's a little stoichiometry problem. We got 15 grams of CO2. Divide by the molar mass. Okay. And then for every 6 moles of CO2, you're going to get negative 2804 kilojoules. So then you just calculate that out. So negative 956 kilojoules with sig figs. We always use our sig figs. There are 3 sig figs in those numbers. This one has 3 sig figs, 3 sig figs, 4 sig figs, so we'd round to the least number, which is 3 sig figs. So if it's negative, it means it's exothermic, meaning energy is being released. If our number was positive, it would be endothermic, meaning that heat is being absorbed.